In this video, we'll begin our discussion over sections 2.4 and 2.5. These are differential equations called exact equations. The best way to go about this is I'm going to start with us actually, our goal in having differential equations is to find the equation that is the answer, right? Find the function that works for a DE. We are going to work backwards to kind of help see how to go about this method on this first example, and then in the next example, I will run through the whole problem. Okay, so solve the following differential equation. They give us this DE. I'm going to think about it anytime I see something like this as that group together. Suppose there's a function that we can find mu that we can find. Doesn't make sense. Okay, sorry about that. For this example, the function we need is that. So they told us that this is the answer. This is the function that we are going to use. And I want to show you something here. I want to take mu, and I want to find mu, and I want to take the partial of mu with respect to x. So that first term y squared is gone. It's a 0. This x squared plus 1. The way I like to think about that is maybe x squared y plus y. Okay, I'm going to get 2xy. The plus y is gone, and then minus 9x squared. All right, I want you to notice something. This is this. Okay, so hopefully maybe you're thinking now, what if I take mu and I take the partial with respect to y? Well, I get a 2y up front. All right, and then here I'm going to have I have a x squared times y, so I'm going to get an x squared. Plus y becomes a plus 1. And then minus 3x cubed is not part of it, right? It's x, and we're doing partial with y. Notice that this is that. Okay, so these type of equations, these exact equations, they actually follow this pattern. You may not be able to see it. It just depends on how fresh you are with your Calc 3. I'm going to replace these partials over in my DE. So that first one in yellow, highlighted in yellow, that is mu of x. Plus the one in that orange color, that's mu of y. And then I have times dy dx. Now, still equal to 0. I want you to think about something, and maybe this is a review for you and you're not seeing it. Recall that if I have a function, and we'll call it mu, and I take the derivative of mu with respect to x, the way I can do this is a chain rule, and it feels silly, but I have d mu over dx times dx, all right? So actually, it starts out not d, and this is the part that's different for the Calc 3 part, is that it's the partial of mu with respect to x, and then we times it by the partial of x divided by the part over dx over dx. Forgive me. So this is dx over dx plus, and then we take the partial of mu with respect to y, and then we have dy dx. This is the chain rule from Calc 3. You haven't had Calc 3? That is something that we go over in Calc 3. There are two ways to think about the chain rule. Those of you that had me, we did both of those last semester. So there is that chain rule. And what we're going to think about now is that, look at the equation that I have above here. This is, those two equations that we just wrote down here and here are the same thing, right? Well, the equal sign on the one above, right? This side is this, right? The dx over dx is a 1, and then it's just a different notation, right? That the partial mu over the partial with respect to x is the same thing as us writing this like mu x up here. So I can actually rewrite this dE here, right? I can rewrite it as the derivative of mu. And that's equal to 0. So what we did is we know for exact equations that we have this. We just observed it, right? That was in our DE above. That was up here. And then we said, okay, well, if we think about it a different way and we write it like this here, in that format, and that says exactly what we have in this equation here, it's the same thing, then I could use the product rule, what's written in red there, to get that. Well, now if I take the integral of both sides, let's do that, d dx with mu dx equals the integral of 0 dx. Well, that gets me mu equals c. So, in this case, the answer to this differential equation is mu, well, we have mu, y squared plus x squared plus 1 times y minus 3x cubed equals c. And that is the answer, my general answer to my equation, right? Because there's a c, it's not my particular answer. So we're going to run through this method and you'll see how this works out. Now, the hard part is, and you're maybe thinking, okay, well, this seemed pretty straightforward. If you think about it for a little bit, it looks pretty straightforward, but the problem is they gave us mu. We knew where to start. That is going to be the method that we're going to be looking at. I am going to leave the theory for the next video, or maybe an optional read. We'll see.